Huawei just launched a phone that is making Apple executives genuinely nervous. Not the kind of nervous where they tweak a marketing strategy. The kind of nervous where they question everything. On November 6, 2025, Huawei opened pre-orders for the Mate 70 Air, and within hours the entire tech world understood this was not just another smartphone launch. This was a direct attack on everything Apple has built over the last decade. The starting price is 4,199 yuan, which converts to roughly $580. Let that number sink in. A premium flagship smartphone with specs that rival or beat the iPhone 16 Pro Max at literally half the price. Official sales began on November 11, 2025, timed perfectly with China's Singles' Day shopping festival, the biggest retail event on the planet. Huawei did not pick that date by accident. To understand why this matters, you need to see what is happening to Apple in China right now. In 2024, Apple saw iPhone shipments in China drop 17%, falling from 51.8 million units in 2023 to just 42.9 million. In the fourth quarter alone, sales collapsed 25% compared to the previous year. Apple went from holding the number one position with 19% market share to falling to third place with just 17.1%. Who is ahead of them? Huawei at 18.1% and Xiaomi at 17.2%. This is the first time since the US ban that Huawei reclaimed the top spot in China, and they did it using technology that was never supposed to exist. Counterpoint Research analyst Ming Zhang confirmed that Huawei shipped 46 million units in 2024, achieving 37% year-over-year growth. While Tim Cook was explaining declining numbers to investors, Huawei was rebuilding an empire. Now let us talk about the actual phone, because the Mate 70 Air is genuinely impressive. The device measures just 6.6 mm thin, making it the thinnest flagship in Huawei's entire Mate series history. But inside that impossibly slim body, Huawei packed a 6,500 mAh silicon carbon battery. The iPhone 16 Pro Max carries approximately 4,400 mAh. That is a 47% larger battery inside a body that is thinner than Apple's latest phone. That should not be physically possible by conventional engineering standards, but Huawei did it. The frame uses aerospace-grade titanium alloy, the same premium material Apple charges a fortune for on its Pro models. It is wrapped in ultra-ceramic glass that rivals Apple's ceramic shield in scratch resistance. The device weighs only 208 grams and carries both IP68 and IP69 water resistance certifications. The display is a 7-inch AMOLED panel with 2760 by 1320 resolution and a 120 Hz refresh rate. For comparison, the iPhone 16 Pro Max has a 6.9-inch screen. The Samsung Galaxy S24 Ultra offers 6.8 inches. Huawei beats both. The camera system includes a 50-megapixel main sensor with optical image stabilization, a 12-megapixel telephoto with 3x optical zoom, an 8-megapixel ultrawide, and a 10.7-megapixel front camera. Charging hits 66 watts wired through USB-C, reaching a full charge in roughly 1 hour, with 50W wireless charging also available. The phone also includes Beidou satellite communication, letting users send messages from remote areas with zero cellular signal. But the real story, the thing that genuinely keeps Apple and Washington up at night, is the Kirin 9020 chip series. The Mate 70 Air comes in two variants. The 16GB RAM models run the Kirin 9020A processor, priced at 4,699 yen for 256GB storage and 5,199 yen for 512GB, translating to roughly $650 to $730. The 12GB RAM models use the Kirin 9020B chip, starting at 4,199 yen for 256GB and 4,699 yen for 512GB. Both chips are built by SMIC using a 7nm N+2 process and are completely domestic. China is not relying on Taiwan Semiconductor, Samsung, or any foreign supplier that Washington could cut off with a single policy decision. Back in 2019, the Trump administration cut Huawei off from American semiconductor technology. The sanctions tightened further on October 7, 2022, when Washington implemented sweeping export controls targeting China's ability to manufacture advanced chips. The United States pressured the Netherlands to stop ASML from selling extreme ultraviolet lithography machines to China, the only tools capable of producing the world's most advanced semiconductors. Without those machines, without Western suppliers, China was supposed to be permanently stuck. According to Tom's Hardware, the Kirin 9020 integrates a fully in-house 5G modem supported by domestic front-end module technology, making it a direct symbol of resilience against U.S. sanctions. Performance benchmarks place it on par with Qualcomm's Snapdragon 8 Gen 3. The chip that was never supposed to exist is now powering millions of phones. The Mate 70 Air runs Harmony OS 5.1, Huawei's proprietary operating system that has evolved significantly beyond its Android root. Inside China, where local app alternatives have fully matured, the software experience is complete and polished. Huawei now produces its own processors, runs its own operating system, and operates a full ecosystem of services and applications. The international sanctions that were designed to destroy Huawei's smartphone business instead forced the company to build everything itself. That vertical integration means no future sanctions can touch them the same way again. The pricing creates brutal pressure across the entire premium smartphone market. Apple asks consumers to pay $1,199 for the iPhone 16 Pro Max. Huawei delivers a thinner body, a bigger screen, a larger battery, and a titanium frame for $580. Samsung, Google, and every other manufacturer now faces the exact same question. How do you justify premium pricing when Huawei delivers comparable or better specifications at dramatically lower cost? The silicon-carbon battery technology alone could establish new industry standards that force every competitor to respond. Traditional lithium-ion batteries may become obsolete in flagship smartphones faster than anyone expected because of what Huawei demonstrated inside the Mate 70 Air. The one honest limitation is the absence of Google services. No Play Store, no Gmail, no Google Maps, no YouTube. Outside China, that remains a significant barrier for international consumers. But inside China, that barrier does not exist. And China is the world's largest smartphone market. Huawei does not need the world right now. They need China. And right now, China is choosing them over Apple in numbers that cannot be ignored. Huawei just tested a machine that only one company on the entire planet has ever been able to build. Not copy. Not reverse engineer. Build. From scratch. And the experts who said this would take China at least 15 years are now watching their own predictions fall apart in real time. Here's the thing though. Before you believe the hype, you need to understand what's actually confirmed, what's still unproven, and why the real story is more interesting than any headline you've seen this week. Let's start with the machine itself. An EUV lithography machine is not a piece of factory equipment. It is the most complex object human beings have ever manufactured. Each one costs over $350 million, more than a Boeing 787 Dreamliner. It weighs 180 tons and needs 40 shipping containers just to move it. Inside, it fires a high-powered laser at tiny droplets of liquid tin to create plasma that emits light at a wavelength of exactly 13.5 nanometers. That light is then used to etch circuits onto silicon wafers. Those circuits are 30,000 times thinner than a single human hair. Only one company in the world, ASML, a Dutch firm, has ever successfully built these machines. It took them over 20 years and a global supply chain of more than 5,000 suppliers across Europe, the US, and Japan. That is what Huawei is trying to replicate. In 2019, the Trump administration put Huawei on the Entity List. Every American supplier, every chip partner, every software vendor was legally cut off overnight. Then Washington pressured the Netherlands to stop ESML from shipping EUV machines to China. Huawei's manufacturing partner, SMIC, Semiconductor Manufacturing International Corporation, was stuck using older DUV technology, which physically cannot produce chips smaller than 7 nanometers. The sanctions looked airtight. Western analysts called it game over. Then in 2023, Huawei shipped the Mate 60 Pro, a real 7 nanometers chip, made in China, without a single ASML EUV machine. TechInsights, the leading semiconductor research firm, tore the phone apart and confirmed it. SMIC had achieved this using a technique called multi-patterning, essentially drawing the same circuit lines multiple times with older DUV equipment to get finer resolution. Something the entire industry said the physics wouldn't allow. It happened anyway. Now in 2025, Huawei is testing something that goes far beyond that. They've built their own EUV machine using a completely different approach called laser-induced discharge plasma, or LDP. Here's how it works. ASML's method fires a laser at tin droplets to create plasma. Huawei's LDP method vaporizes tin between 2 electrodes and hits it with a high-voltage electrical discharge instead. Different mechanism, same result. 13.5 nanometer wavelength EUV light, the exact frequency needed to etch 3 nanometers circuit. The design is simpler, smaller, and potentially a fraction of ASML's price. A patent for this technology was filed with China's National Intellectual Property Administration in 2023. Trial production is targeting Q3 2025. Mass production is targeting 2026. Now here is where we slow down and fact-check. The patent is real. Multiple independent Chinese research teams, including one at the Shanghai Institute of Optics and Fine Mechanics and another at Harbin, have separately confirmed achieving 13.5 nanometers light source breakthroughs. That part checks out. What has not been independently verified is whether this machine actually works at commercial scale. There has been no third-party teardown, no external confirmation of output quality. The sources are patents, leaks, and state-adjacent media. So the technology concept is scientifically sound. Whether it performs reliably in a factory environment is a completely different question. The number that matters most here is yield rate. If you make 100 chips and 90 work, your yield is 90%. Commercial viability requires at least 70%. TSMC runs at 90% plus on its 7 nanometers process using EUV. SMIC doing the same 7 nanometers node with DUV multi-patterning hits around 50%. At 5 nanometers that drops to roughly 30%. At 3 nanometers using this new method, analysts estimate initial yields could be as low as 10 to 15%. That means 85 to 90 chips out of every 100 fail. Each working chip becomes extraordinarily expensive, even after China's government subsidies covering around 30% of production costs. This is the part most videos won't tell you. A patent is not a product. A lab breakthrough is not a factory. But here's what you also cannot ignore. NVIDIA, the company with a $5 trillion market cap that powers almost every major AI model on the planet, warned its own investors about Huawei's gains. That is a legal disclosure, not a press release. When Huawei announced the Ascend 910C, a chip that reportedly matches the performance of NVIDIA's H100, NVIDIA's market value dropped $127 billion in a single day. Then researchers at Peking University published a paper in Nature Electronics describing an analog computing chip that processes matrix calculations 1,000 times faster than the NVIDIA H100 while consuming 100 times less power, and they built it using 7 nanometers technology that the US never sanctioned because everyone assumed it was too outdated to matter. Jensen Huang, the CEO of NVIDIA, stood on stage at the Financial Times AI Summit in London and said directly, "China is going to win the AI race. Not might win. Will win." So here is the honest verdict. The 15-year gap is fiction. That is confirmed. 3nm chips flooding the market by 2026 is also probably fiction. In March 2025, photos leaked from inside a Huawei facility in Dongguan, China. Engineers around the world opened those images expecting to find nothing. What they found instead made ASML's stock drop 7% in a single session. There was a machine sitting inside a clean room that, according to every Western semiconductor expert alive, should not exist. China had built its own EUV lithography machine. Then 3 weeks later, researchers at Fudan University published a paper in Nature describing a chip with an active layer thinner than 1 nanometer. 2 breakthroughs, 1 spring. And the blockade the United States spent years constructing started showing cracks that nobody can explain away anymore. To understand why this matters, you need to understand what ASML actually is. This quiet Dutch company based in Eindhoven makes exactly one product: extreme ultraviolet lithography machines. Every iPhone ever made, every NVIDIA GPU powering ChatGPT, Claude, every AI model you've touched. None of it exists without ASML. Their machines fire a 30-kilowatt laser at microscopic tin droplets 50,000 times per second, generating plasma hotter than the surface of the sun, releasing light at a wavelength of 13.5 nanometers that etches circuits onto silicon with atomic precision. Each machine costs $380 million, weighs 150,000 kilograms, requires 250 shipping crates just to transport, and is assembled from over 100,000 parts sourced from 800 suppliers across the world. ASML spent over 20 years building this technology. In 2019, the United States turned it into a weapon, pressuring the Netherlands to block all EUV exports to China. The logic was simple and seemingly airtight: no EUV, no chips below 7 nanometers, no advanced semiconductors, no AI dominance. Game over for Beijing. Then August 2023 happened. Huawei released the Mate 60 Pro. Tech Insights, the most respected semiconductor research firm in the world, bought units, cracked them open, and confirmed what looked impossible: a genuine 7nm Kirin 9020A chip, manufactured inside China by SMIC without a single ASML EUV machine involved. SMIC did it using older DUV deep ultraviolet equipment and a technique called quadruple patterning, running 34 lithography steps where EUV needs only 9. One engineer described it as painting the Mona Lisa with a house brush. It works. It costs 40 to 50% more per chip than TSMC's equivalent. Yields sit below 50%. By any normal business logic, it's financial suicide. But Beijing isn't running normal business logic. Between 2022 and 2024, the government funneled over $75 billion into domestic semiconductor development. Government subsidies covered 87% of SMIC's entire operating profit in 2024. More than 50,000 engineers were pulled from companies like Huawei and SMIC and redirected into classified research facilities. This was never about profit. It was always about making sure no foreign government could ever again threaten to switch off China's entire technology sector with a policy memo. Now back to Fudan University. The chip is called Wuji, a 32-bit RISC-V microprocessor built not from traditional silicon but from a 2D material called molybdenum disulfide. Its active layer measures less than 1 nanometer thick. It contains 5,900 transistors. The previous world record for a 2D semiconductor circuit was 115 transistors, set in 2017 by researchers at Vienna University of Technology. Fudan didn't inch past that record. They cleared it by a factor of 51 in a single leap. The same team built a flash memory device called POX that writes data in 400 picoseconds, roughly 25 billion operations per second, with a 94.3% yield rate in controlled lab conditions. Here's the honest truth though, this chip cannot run an app. It cannot power a phone. It cannot train an AI model. There are 80 billion transistors inside a modern processor. 5,900 is not a gap from that number. It's a canyon. What Fudan proved is that the physics work at atomic scale using 2D materials. What they didn't prove is that anyone on Earth can manufacture this at volume, because nobody can yet. But here's what matters. Every hard line drawn around what China could not do has been crossed. 7 nanometers without EUV was physically impossible. It happened. The 1 nanometer research is the flag planted for the next decade. Back to those photos from Dingguan. The equipment spotted inside Huawei's facility was traced to the Chongqing Institute of Optics. The underlying technology is called LIDP, a laser-induced discharge plasma, developed at Harbin Institute of Technology. Instead of blasting tin droplets with a massive laser the way ASML does, the LIDP method vaporizes tin between 2 electrodes using high-voltage electrical discharge, producing the exact same 13.5 nanometer EUV radiation through a completely different mechanism, one that reportedly consumes 40% less power than ASML's approach. Current LIDP prototypes produce between 50 and 150 watts of EUV power. Commercial manufacturing requires at least 250 watts. ASML's latest machines push past 500 watts. The gap is real. Chinese officials targeted trial production for Q3 2025 and mass manufacturing for 2026. Independent analysts say 2028 to 2030 is more realistic. These are the same analysts who said 7 nanometers without EUV was impossible. That context is everything. Even a machine producing 70% of ASML's output would be revolutionary for SMIC, which is currently burning through 34-step workarounds that make every chip they produce dramatically more expensive than anything coming out of Taiwan. And TSMC is watching. In the second half of 2025, TSMC began mass production of 2 nanometer chips using gate-all-around transistor technology for the first time, with yields reportedly above 60%. Apple, Nvidia, and AMD already locked in capacity. Samsung entered 2 nanometers production too, but is stuck around 40% yield compared to TSMC's 90% at 3 nanometers, a gap that translates to billions in wasted silicon every single month. TSMC itself says it won't reach 1.4 nanometers until 2028, and true 1 nanometer mass production isn't expected before 2030. Every step of that roadmap depends entirely on ASML machines that China cannot legally buy. Meanwhile, Huawei's Ascend 910C is already shipping at roughly 780 to 800 teraflops of BF16 performance, about 40% of Nvidia's H100 at 2000 teraflop. Huawei plans to ship over 700,000 Ascend units in 2025 alone, scaling to 1.6 million chip dies by 2026. The next chip, the Ascend 910D, reportedly targets H100 level performance on specific workload. When that report circulated on April 28, 2025, Nvidia lost 2% of its market value in a single trading day before a single specification was independently verified. China currently depends on foreign chips for 60 to 70% of its AI infrastructure. By 2026, analysts project that falls to 40 to 50% as Ascend production scales. The direction is not reversing. The 1 nanometer chip is real science. The EUV machine is a real prototype. The gap is real and measured in years. But the team trying to close it has $75 billion, 50,000 dedicated engineers, and absolutely nothing to lose. Watch this space. On December 6, 2025, A patent quietly published by China's National Intellectual Property Administration stopped semiconductor executives cold. The document's title was Dry and Bureaucratic: Metal Integration Method for Manufacturing Integrated Devices, and for a few hours nobody noticed it. Then the engineers started reading. And the silence became panic. Because buried inside that filing was something that should not exist. A detailed technical blueprint from Huawei, the Chinese tech giant locked out of advanced chip-making equipment since 2019 for manufacturing 2-nanometer chip. The same cutting-edge technology that TSMC, Samsung, and Intel collectively poured over $100 billion into developing. Except Huawei is claiming they can do it without the machines they are legally banned from buying. To understand why that matters, you need to understand the machines. ASML, a Dutch company, is the only manufacturer on Earth of EUV lithography machines, the absolute gatekeepers to advanced chip production. Each one costs over $150 million. They weigh 180 tons. They require 40 shipping containers just to transport. Inside, they fire laser-produced plasma at tin droplets to generate light with a wavelength of just 13.5 nanometers, a beam so precise it etches circuit patterns onto silicon that make a human hair look like a highway. The entire semiconductor industry agreed on one thing: without EUV, you cannot manufacture chips below 7 nanometers. That was not an opinion. That was physics. Only TSMC, Samsung, and Intel had these machines. In 2022, the Netherlands blocked ASML from selling to China. The cage was complete. Then Huawei started doing things that were not supposed to happen. In August 2023, they released the Mate 60 Pro smartphone. Western analysts tore it apart looking for the trick. There was no trick. Inside sat a genuine 7-nanometer Kirin 9020A chip, manufactured by SMIC, China's largest chipmaker, using older DUV deep ultraviolet lithography machines that nobody had bothered to sanction because everyone assumed they were too primitive to matter. TechInsights, the leading semiconductor research firm, confirmed it after a full teardown. Zero ASML. Zero EUV. A chip that defied a decade of Western assumptions, shipping in a phone that sold out within minutes. Then in 2024, the Kirin 9030 pushed toward 5-nanometer equivalent performance. Every time the world drew a line and said China cannot cross this, Huawei and SMIC crossed it anyway. So what exactly is in this new patent? The method is called self-aligned quadruple patterning, or SAQP. The idea is ruthlessly simple in concept and brutally complex in execution. EUV draws an ultrafine circuit line in one single laser pass. SAQP draws that exact same line in 4 separate passes using older DUV equipment, with precision-engineered stencils and spacers guiding each pass down to atomic-level accuracy. The patent describes 5 spacer layers and exotic metals, ruthenium, copper, and cobalt, woven together to create metal interconnects spaced less than 21 nanometers apart. On paper, it is a work of engineering genius. In practice, it is one of the most expensive gambles in the history of chip manufacturing. Here is the brutal math. TSMC running their 7-nanometer process with EUV achieves around 90% yield, meaning 90 out of every 100 chips they produce work perfectly. SMIC doing the same 7 nanometers node with DUV multi-patterning hits only 50%. Drop to 5 nanometers and that bleeds down to 30%. Now push all the way to 2 nanometers. Industry analysts estimate initial yields using Huawei's method could fall as low as 10 to 15%. That means 85 to 90 chips dying on the production line for every one that survived. Chinese-made chips already cost roughly 40% more than an equivalent TSMC chip, even after Beijing subsidizes around 30% of production costs. At a 10% survival rate on 2 nanometers, each working chip becomes extraordinarily expensive. And China is doing it anyway. Because this was never a business decision. Between 2022 and 2024, Beijing funneled over $75 billion into domestic semiconductor development through state banks, sovereign wealth funds, and tax incentive. More than 50,000 of China's brightest engineers were reassigned from companies like Huawei and SMIC into classified research facilities. In 2024 alone, government subsidies covered roughly 87% of SMIC's entire operating profit. Beijing is not building chips to make money. It is building chips to make sure no foreign government can ever again threaten to switch off China's entire technology sector with a single policy memo. That is a different calculation entirely, and no amount of economic logic changes it. But the patent is only half the story. In early 2025, reports emerged that China was testing its own extreme ultraviolet lithography machine, a prototype believed to be codenamed Hyperion 1, at Huawei's Dongguan facility. The approach is completely different from ASML's method. Instead of firing high-powered lasers at tin droplets, the Chinese system vaporizes tin between electrodes using high-voltage electrical discharge, a technique called laser-induced discharge plasma, or LDP. Both methods generate the same 13.5 nanometer EUV wavelength needed for advanced chip etching. The current prototype produces between 100 and 150 watts of EUV power. Commercial manufacturing requires at least 250 watts. ASML's machines produce over 500 watts. The gap is real, but the fact the prototype exists at all was enough to send ASML's stock down 7% the day the news leaked. Meanwhile, TSMC is not standing still. Their 2-nanometer process entered mass production in 2025 using next-generation EUV with high numerical aperture optics and gate-all-around transistor architecture. They spent over $40 billion on R&D and new fabrication facilities. Their yield from day one sits at 85 to 90%. Their customer list reads like a who's who of global technology: Apple, Nvidia, AMD, Qualcomm. TSMC controls approximately 60% of the global foundry market and nearly 90% of advanced chip manufacturing. None of those customers are leaving anytime soon. But if Huawei cracks 2 nanometers production, even at higher cost, they can supply China's domestic market of 1.4 billion consumers. Companies like Xiaomi, BYD, Alibaba, and ByteDance would route to Chinese foundries instead. That is potentially 30 to 40% of global semiconductor demand shifting ecosystems permanently. A patent is not a chip. There is zero evidence today of actual 2 nanometers chips being produced at any scale using this method. Going from patent to mass production typically takes 5 to 7 years minimum, and TSMC spent 30 years building relationships with over 600 global suppliers to get where they are. That ecosystem cannot be rebuilt overnight. But here is the thing nobody can argue with anymore. In 2019, a 7 nanometers chip without EUV was called physically impossible. It existed by 2023. A 5 nanometers equivalent without EUV was called physically impossible. It happened in 2024. The 2 nanometers patent may be the next chapter in that same story. Or it may sit in a drawer and never see production. Nobody actually knows. But the wall that everyone said was unbreakable, it has cracks in it now. And the next 24 months will tell us exactly how deep those cracks go. The year is 2025, and something impossible just happened in a secret facility in Dongguan, China. Huawei, the company that was supposed to be dead after US sanctions, just successfully tested their own extreme ultraviolet lithography machine. If you don't know what that means, let me put it simply. They just built the most complex piece of technology on planet Earth, a machine that only one company in the entire world has been able to manufacture until now. And they're using it to make 3 nanometer chip. The same experts who said this would take China 15 years are now watching their predictions crumble in real time. Let me explain why this is absolutely insane. An EUV machine is not just another piece of factory equipment. These machines cost over $350 million each, more expensive than a Boeing 787 Dreamliner. They require 40 shipping containers just to transport. Inside, they use light with a wavelength of exactly 13.5 nanometers to etch circuits onto silicon wafers that are 30,000 times thinner than a human hair. For decades, only ASML, a Dutch company, could build these machines. They had a complete monopoly. No competition. Zero. And when the US government pressured the Netherlands to stop selling these machines to China in 2019, everyone thought China's semiconductor dreams were finished. Here's what happened instead. In 2019, the Trump administration hit Huawei with sanctions, cutting them off from American technology and advanced chip tools. ASML, under pressure, stopped shipping EUV machines to China. Huawei's chip-making partner SMIC, which stands for Semiconductor Manufacturing International Corporation, was stuck using older DUV technology, which maxes out at 7 nanometers. The sanctions appeared to work perfectly. China's access to cutting-edge chip technology was completely blocked. Western analysts, semiconductor experts, and policymakers all agreed this was game over for China's chip ambitions. But instead of giving up, China went into full wartime mode. They poured billions of dollars into research and development. Xi Jinping made semiconductor independence a national security priority, comparable to food security or energy independence. Universities, private companies, and state-owned enterprises were coordinated in a massive push toward technological self-reliance. And now, in 2025, we're seeing the result. Huawei didn't just try to copy ASML's approach. They invented something completely different called laser-induced discharge plasma, or LDP. While ASML uses laser-produced plasma that blasts tin droplets with high-powered lasers, Huawei's LDP method vaporizes tin between electrodes and zaps it with high-voltage discharge. This creates plasma that emits the exact same 13.5 nanometer wavelength of extreme ultraviolet light needed for chip manufacturing, but through a fundamentally different mechanism. And here's the kicker. It's simpler, smaller, and potentially much cheaper than ASML's hulking machines. This LDP-based EUV system is already in testing at Huawei's Dongguan facility. A Chinese firm, rumored to be China's lithography champion, filed a patent for this technology in 2023, and now it's coming to life. Trial production is scheduled for the third quarter of 2025, which is just months away. Mass production is targeting 2026. If this works, China could flood the market with homegrown 3 nanometer